Only 2 people on here. All right, we'll get started shortly. We got only 2 people on here, so that's not good, but we'll crank up in a second. We'll let a few more people get logged in. I'm not sure how 115 turned into 120, but it's okay. Actually, you know what? Share my screen. All right. Let's see. Is everybody in here logged in? No? All right. Yeah, the only reason I'm asking you to is because of the notes. I'm not gonna write on the board. Where the heck is everybody?
A lot of people are saying that it hasn't started for them, but I just told them that it started.
I am the host. I'm not sure why. Yeah. Somebody just got in. Which one of y'all is Danielle?
Hi.
Either. Okay. It's weird. But it's launched and I'm in and I got video and audio, so I'm not sure why it's not. Maybe there's something going on with y'all on the TU Wi-Fi. That might be the problem.
No, I'm home.
Okay. But that's not the problem. It's so weird. Let me make sure I don't have a waiting room. Nope, no waiting room. Let people trickle in. Thankfully, it's a short layout.
Will there ever be labs that are really 4 hours long?
For this, maybe 3, but I don't know about 4. We used to have labs that were that long, but we kind of cut them out and just switched over to doing some different labs. How am I in the
Okay.
hold up? But yeah, but this semester probably not. I'm not in another meeting. Are y'all using the link from I sent out in Blackboard? Yeah, and it says I'm in another meeting. This is dumb. Let's see what the meeting ID is.
Yeah, maybe put a different thing.
Yeah, so it's 896. Hold up. Let me go back. So right. Yeah. That's the right.
896 0786.
Yep. 0451.
That's the old. That's when you fit the first one.
Did I send a different one?
Yeah, the one from last class was not the.
It's weird. So let me go back to Blackboard and send that link out right quick.
It's gonna be in there.
I can send it out. Not sure how that happened. Unless I sent y'all the link for part one. I mean, the first section, which is quite possible. You
But
know,
it's still the same if we had left.
yeah, I might have, I know I might have hit copy, but it may not have copied. That's okay. We're gonna fix it.
Shiloh.
Really? Wilding on a Wednesday. Wild out Wednesday. All right, let me make sure. Yeah, that's probably the link from Tuesday. Tighten up, Russell. That's clearly my fault. I'll send the right link out though. Just give me 1 second. Stuff like this will make the lab take 4 hours.
So, because of COVID, again, we're at progress report stage. If you aren't where you need to be, I do encourage you to read.
Hold up. We should be good. I do know how it happened. But it's water under the bridge now. Come on. All right. So that ought to bring the rest of the people in limbo in. All right, let me share my screen back again. It's coming up. Can everybody hear me? Okay, that's streaming right now.
Yes.
All right, cool. All right. This around. So today we are doing recrystallization, and we are taking the crude aspirin, which we made last week, and we're going to purify it. It's a solid, and one of the ways to purify solids is to do what's called a recrystallization, right? So we're just gonna right? And so what we need is, in order to do this, if you watch that video that was sent out, you need a solvent that won't dissolve your compound at room temperature. So a solvent in which product, I'm going to abbreviate product, is insoluble at room temperature. But you need it to be soluble at higher temperatures. right? So that's the purpose of using ethanol. Remember, if you're in my lecture, we talked about this when we talked about solubility, that like dissolves like. So aspirin, which is acetyl salicylic acid, which is this compound that's shown right here, is polar. So you need a polar solvent. So ethanol is a polar solvent. All right, so we're going to use ethanol today. And there's also going to come up a time in the recrystallization where we add water. And when we add water, what we're going to do is force the aspirin out of solution, because that's going to cause the aspirin to precipitate, but then it'll leave behind in the water ethanol layer the rest of the crap that happens when you run this reaction. So you could have some leftover acetic acid. All right, so you got acetic acid that's probably left over, and you probably have some acetic anhydride that's left over, right? So that the purpose of this process is to get rid of all of that extra stuff and get the pure aspirin in its pure form. All right, so you need ethanol, and then you need cold water, not written with a highlighter though. So that's going to make the aspirin precipitate. All right. And then, so this is a fairly simple process. The only problem that can happen, well, there are two problems. One problem is you can overheat your ethanol, which would be bad because it will ignite. The other problem is you can oversaturate your sample. So this experiment is going to call for, we're going to start with 20 mils, or actually 25 mils. Of ethanol, but it is more than likely not going to take, excuse me, all 25 milliliters. All right. What we found yesterday was the average amount of ethanol that it took to dissolve up the aspirin sample was about 12 mils, which makes perfect sense because we cut everything in half when we did the first experiment, the synthesis. And so the amount of ethanol that it would normally take to dissolve up 14 grams of crude aspirin, this should also be half. All right, so we're going to start with 25 mils. You're going to heat that ethanol until it's near boiling. And even though the video showed you the use of boiling sticks and all that stuff, we're not going to use that. We don't need it. Certain solvents, you do need that to prevent them from bumping. But this, if it gets to the point where it starts boiling, just take it off the hot plate and sit it on the bench top. All right, so heat it up until near boiling. You're going to add initially around 10 milliliters. Right, and the reason we're going to add that much is because the aspirin itself is a very fluffy solid, and so if you don't add enough ethanol, you're not going to be able to heat it when you put it onto the hot plate. So we're going to start out with about 10 mils. You're going to eyeball it, estimate it, and then you're going to put your sample after you add the hot ethanol onto the hot plate and swirl it, and keep swirling it until it dissolves. Right? If it doesn't go into solution, you keep adding small increments of ethanol until all of it goes into solution. But you shouldn't need more than 15 milliliters to get it to all dissolve. So I'm going to say the max is going to be 15 mils. Right? If you add more than that, then it's probably going to get super saturated, and then we're going to have to do some other techniques to try to recover that aspirin from solution. All right. Any questions? My handwriting is terrible, but that's because I'm trying to hurry up and get to the good part. So a max of 15 mils. We're going to each start with 25. So I'm going to pass the ethanol around. So I'm going to start with you right here. And take that, add 25 milliliters to your gravity. And now I'm going to actually log in from my iPad. So if you're on the stream, go ahead and pin my iPad when it comes up, and that way you don't have to search for the video. Oh, let me stop sharing so I can actually see the meeting ID. 896-0786-054. Oh, that's tight though. All right. So I'm gonna not enable the audio so I don't get that feedback. All right, so I'm gonna train this on one of y'all who's actually doing the experiment. Let me move it back here. Y'all, start. Don't mind.
No.
You got people permission. Put them on camera. All right, so go ahead and once you measure out the 25 mils of ethanol, go ahead and turn the hot plate on about 3. And stick that on top of the hot plate so it can start heating up. So put that in the early mark flask and then put it in the smaller. All right. One of the things that data sheet is going to ask you for is the crude yield. And so what I'm going to do is take one sample and we're going to use that number for our crude yield. So I'm going to weigh out a sample real quick and I'll put the crude yield value in the chat. All right, so give me a second while everybody's getting their ethanol. And I'll do that. All right, so we're gonna take these aspirin samples from last week, crude ones. All right, and let me show you an example of a good run and a bad run. All right. So if you look at this aspirin right here, you can see it's kind of shimmery looking. It's shiny, and that's good. If it's crappy, it's going to look like baking soda, caked up baking soda, which is exactly, well, this one's not that bad. Let me get another one that's actually bad. And that's not a bad thing that it's bad, it just is what it is. All right, this is a bad batch right here, crude, but it's fine if it's bad because that's the whole purpose of us doing the lab is we are purifying. So it doesn't matter if it's bad. When we purify it, it's going to make it better. But as it is, it looks crappy, right? It looks like caked up baking soda. When you compare it to this, which is nice and shimmery, kind of fluffy looking, kind of get it right in the right spot. Right? So yeah, so that's what we're doing. So go ahead and start. We'll give you this fast now. Because I think you're a miracle. Really draw that compliment. So take that and add it. We go to the stop here. If you're streaming, just hold tight. I got to make a run to the stock room.
Oh, you are you eat organic chem. All that you was like, oh no. Yeah. I have messed up and so I have messed up and so so we told her to do it. No, it's just I was just about it.
I want to say, put that on there. But before you start heating it, go ahead and transfer that. All right, everybody's gonna need a sample. I'm gonna even do one myself. All right, so what you're seeing now, I think. Yeah, let me move this up. She's transferring that crude aspirin to an early Meyer flask. All of it. The only thing we're gonna save is a little residue because when we take the melting points, we're gonna need some crude aspirin to compare the pure melting point to. And while you're at it, I think, is there a place on that data sheet for melting point? I think it's on there somewhere. Go ahead and look up what the expected melting point for aspirin is.
Yeah, no easy way to say it.
Try to do it. I have faith in you. Letting me down already.
Oh, I ain't really, yeah, it's going in
But
there.
there's a will, there's a way. All right. Ooh, Lord. All right, y'all.
You said melting point of crude aspirin?
Say that again?
Did you say look up the melting point of crude aspirin?
No, the expected melting point of aspirin.
Oh, just, okay.
Yeah, because you may find the crude somewhere that somebody has posted, but I'll much rather you find the expected melting point. Because that's what we're going to compare the crude to, because it should match up. All right, everybody good? Yeah, I'm gonna spill it got going on. Quite a bit, quite a bit. All that cleaning I just did.
I'm sorry.
We got one. Spillage is good. That means you work. If your bench top is not dirty, you're not working. So that's good. Sorry, I'm not gonna say nothing else. We're gonna, just save the paper, put it up top. Now you can start heating your ethanol. The reason I didn't want you to start heating it is because it warms up pretty rapidly. So I didn't want it to be boiling while you were doing that. Let me get that. Good job. You want to watch that ethanol closely. Don't let it boil. If it starts boiling, take it off the hot plate, sit it on the bench top. And you can go ahead and be heating yours up too. Everybody get 25 mils of ethanol. Go ahead and put that in that second oven mark. Get a second. Is that wet? You go get your another. I'll get you another. So again, you don't want to overheat ethanol. Yesterday, I told the class about an incident that happened where a student was heating it and they weren't watching it, and the whole flash caught on fire, and they were still just sitting there, oblivious to the fact that it was a flaming flask of ethanol right next to them. So pay attention to it. When it starts boiling, take it off.
Dr. Russell,
Go ahead.
is there any way you can post like the data from last class on a slideshow? Because it was kind of hard for me to keep up of like where to put most of it. Last
You mean
class.
all the data that we collected last time?
Yeah, if you can put it on like a slide and like post it on Blackboard.
Okay, all right, I can do that.
Okay, thank you.
I have a question as well.
Go ahead.
Do you want us to add, for the expected melting point of aspirin, do you want us to add that to the chart for the recrystallization?
It's not on there already?
Chart? No, not that I can see.
Is there a melting point section?
No, there's not one on here.
I added that. That's okay. You can put it at the very end. Because we're definitely going to take the melting point and we're going to compare the aspirin and the crude and pure. And so it's going to be two totally different numbers. So just go ahead and add it. I'll update it later because I want to update it and then have to refill out the form. So just add that section at the back. Fill it out. It's not gonna fit on the photo. Where'd you get the paper? Was it clean? Right.
Dr. Russell,
Go ahead.
the MP/BP is the melting point and boiling point section.
No, that's on the date. That's on the reagent table. That's different.
Okay,
The melting point, boiling point is going to be for like acetic anhydride, and because it's a liquid that's melted, you need a boiling point, and then salicylic acid has a melting point because it's a solid.
I'm sorry, what was the first thing you said?
When? Just now?
Yeah, you said, I heard the second part of the sentence, which was the expected boiling point of aspirin. What was the first part of the sentence?
That's not what I said. That's not what I said. So somebody was asking if the section on the reagent table had anything to do with the melting point of aspirin, and the answer was no. That the melting point, boiling point section on the reagent table on the data sheet is strictly for looking up the melting point of salicylic acid, which is one of our star materials, and it's a solid, so it's going to have a melting point, and then acetic anhydride, which is the other star material, which is a liquid, so it's going to have a boiling point.
Okay, thank you.
Yep, no problem. All right, anybody ethanol heated up there? No. Y'all had Eli's hot plate last time, it would already be exploded. But that thing, I'm glad nobody picked that up. No, it's boiling, so hold up before you do that. Let's get all that other crap off the fish. Coming back, like the waiter. All right, so you can actually take that off the hot plate, the ethanol, hit it, and then you could go ahead and add your first 10 mils. Let me come back here. Action. go ahead and add. what I'm looking like.
Yeah.
Go ahead and add that first 10 mil. That's liquid to solid. Add about 10 mil, just eyeball. Then I'll fix it. Going. I stop. Now you can sit that on top. Continue to swirl that until it goes in the solution. It's out like that. See how that looks like a slurry? You want to have it on. I'll add a little bit more. All right, that's good. Swirl. Now it's all hot on the backside. It's like boiling. Take it off. All right. I'll do it back here. You'll start not boiling here. I'll take you start.
We have to,
It's close to boiling though. You look close at it, you can see what the waves was close. All right, anybody got any questions that's streaming? Just keep swirling. I know it looks like it's not going, but it's going. All right, so today, once we do the recrystallization, we're also gonna do another vacuum filtration. So we'll have a butyl funnel, filter adapter, vacuum flask, and hook that up to the aspirator on the faucet. All right, so you can see now, that aspirin is starting to go into solution as the temperature increases with the solvent. That's good. You don't want it to go in as soon as the solvent hits it, because then that means that the solvent was it was too polar or it was too soluble in that solvent. You want it to be insoluble at room temperature. And then as the solvent heats up, then you want it to go into solution. So this is good. Don't worry about it. Right. So add liquid stop. Walk with about 10 ml. All right, let's move it. If it doesn't, start going into solution. Add more hot water. It's got to be hot and cold. So we're working with over there. We got the hot plate from Georgia. Sitting on the porch drinking tea, eating biscuits. Eating cold stuff. Let's get close. It don't look like you got what's going on, what's actually going on. I want to hold pressure on that. And you can rent that. That's a lot of action. You don't want to throw that away. Got water on it. Real cold. So you'll have ethanol, like you're boiling all. You don't have a little bit. So we got see now, this sample, already have that actual drawing solution, so that's good. Taking a while. But I'm supposed to get 5 now, 2 minutes. About 2 minutes, so that's good. Slower it goes to the solution, the better. That means number one, it's not gonna be oversaturated. And number two, the solubility is not gonna be a problem. So, well, you might want to add another little drop of ethanol. Not much. Maybe another little. How we got this sample also going in? Slow, better. Slow is always better. I'm gonna pray if they can on this one. About the ball. I'll give about-
Dr. Russell,
Go ahead.
can you like mute your computer and then maybe like unmute the iPad? Because you're like, it sounds like you're really like far away. It's hard to hear what you're saying.
All right, I got that same complaint yesterday. I didn't learn my lesson, but I will do that. All right. Hold up. Turn the volume down too. All right. Yes, no. Better.
That's a
Yeah,
lot
that's
better.
fair.
All right, bet. I wasn't saying anything. I was just talking trash to the people in the back. So you good. You didn't miss anything. All right. Let me see what you got over here. That's all in solution. That's awesome. No particles floating around. So that means that you will not need to do a hot gravity filtration. You only do that if you have insoluble impurities in your solution. But because there's nothing floating around in there, that's great. So I'm gonna take this. So you don't confuse the two flasks, even though they get started. So you can take that off. Let that be cool in the room temperature. Take your graduated cylinder and get 25 milliliters of cold distilled water, which is up front. It's in a jug. Bought it from Family Dollar just for this purpose.
So how much ethanol did they use?
The total, can you pour, hold up, let's do this. Let's pour back into a graduated cylinder what's left. So she started with about 25 total, and now it's about 10 mils left. So she used about 15 milliliters total. And it took about 7 minutes, which is also a question on that data sheet. All right, so we're still waiting on this one, this flask of ethanol to boil. But it's coming.
Did we, the crude yield of aspirin, what was that?
I'll give you that number in a second.
Okay, okay.
Once we get the ice bath set up for the recrystallization, I'll give you the crude yield. I just have to weigh out a sample.
Okay, thank you.
Because we're gonna use one sample for that number. Everybody's gonna use the same number.
It's more, a little bit.
That's fine. It's probably hot enough. Just go ahead and add about 10 mils again. Just kind of eyeball it. And too hot. Need some help. Let me help you, child. I got it. There, Paul. Yeah, I feel powder. I don't know if that's- Put that on the hot plate, turn the heat down, and then sit your ethanol on there too. And just, there you go. Make sure they don't bump and you don't knock it off. Just keep feeding it.
Dr. Russell,
Yes.
a little bit ago, whenever y'all poured the ethanol in it and it fully dissolved, and then you had said if it had impurities or any particles left over, there was like a type of filtration you could do.
Yeah,
What was that?
Hot gravity filtration. You could check no on that box.
Okay,
Yeah, because none of the samples that we have done so far have had to do that. So just check no on the hot gravity box.
okay, thank you.
That you only do that if everything goes in the solution, but you got some insoluble impurities that won't go. Then you just take what you have, filter it through a glass funnel, and then recrystallize the liquid that you get from that. Okay, so you can go ahead and add. Hold on, no, you can add water to that. Go ahead and add water to it. Yep. So you'll see it get a little cloudy. You can see that clouded up just a tad, but the aspirin is not going to come out at room temperature, not right away. So we need to make an ice bath. So we're going to take a beaker. Go ahead and make one. You already had the water. Yeah, beaker. Dip it in that cooler up there. So you're gonna take that. You can see a few crystals starting to form on the bottom if you look closely. But when we cool this down, it's gonna facilitate that process of crystallization. This is another thing that you don't want to happen rapid. You want it to be slow. The slower the crystals form, the more pure your aspirin is gonna be. All right, so you can see them forming good now. All right, so we're gonna take this aspirin, we're gonna sit it right down in here. Yep. And watch paint dry. So you don't want to disturb it, so don't touch it, twirl it, twist, nothing. Just let it sit. All right, and we got your aspirin is almost dissolved, which is good. You might want to add about another ml of ethanol. It's a small amount. I got it. Yep, that's good. And then you can just keep eating. All right, anybody have any questions? So the recrystallization part is really like an art form because it's easy to screw up, but if you get it right, you get really pure products. The key is to know what solvent to use and to make sure you don't oversaturate your product. All right, that's good. Slow is good. Now got crystals back here. Good. All right, so you can see this one is also kind of chilling on the ice bath, which is good. Can you lift that up? The flask. You can see right, hold it up more. Yeah, you can see right away that there's a lot of aspirin at the bottom of that. So that's good. The next step is to do the filtration, the vacuum filtration. And you can see with this sample, there's a lot more aspirin now than there was before. All right, so we're just gonna leave it. The more undisturbed it is, the better. All right. Any questions about anything? That one is almost done. Let me see. Still got a little aspirin floating around at the bottom. sit it down. Like keep the heat on it. Like that. So to stay in contact with it. See how that went in that quick? Just have to keep it in contact with the hot plate. Great. Go ahead and get your water. You can take that off and sit on the bench top. All right, let me weigh out this sample so I can give you this crude yield. And then that's the last number you're gonna need because everything after this is just filtration as well as cleanup. And since you've already seen us do vacuum filtration before, there's no sense in watching paint dry if you don't have to. So today I'm gonna get fancy and use a weigh boat, which is good. You expect the crude yield to be somewhere around what you started with, so somewhere between 6 and 7 grams. So I got a sample right here that I'm going to weigh out. Just want to break it up some. Zero off the balance. Stay at 0. Stay where I put you. So we're going to again save some of this. Just mostly what's stuck to the filter paper. Oh, speaking of filter paper. All right, so we got let me finish weighing this out, and then you can put this number in for your food deal. .705. That's the crude. 6.705. I'll write it. I mean, I'll put it in the chat also.
Gravity filtration wasn't necessary, right?
Say that again.
Gravity filtration wasn't necessary, right?
No hot gravity filtration. So 6.705. That's the crude yield. Everybody can use that value, even y'all, y'all starting with 7, 8, almost 8 rounds. Don't worry about that. All right, so while everybody's waiting on the after the crystallize, let's go ahead and get the vacuum filtration stuff set up. So you need a phone. If you don't have a piece of rubber, tool hidden close by you, and there should be some on the cart. All right, anybody got any questions about what we've done so far?
I have a quick question. When it kind of might be what we were supposed to already do, but it was on like the percentage yield. So like
Yeah,
you just
so-
gave us the crude yield. Would that be the actual yield we got, or is
No,
that going to be
no.
the purified?
Yeah, the actual is based on the pure sample.
Okay, but we could figure out the theoretical, but we can't do the actual and percentage yet.
Right. Correct.
Okay.
You can't figure out the actual until you get a purified sample that's been dried.
Okay. Okay.
So we're actually going to probably take next week and let it dry fully, because sometimes it takes a while for it to dry in these conditions.
Okay.
So next week we may not meet physically. It may just be like a lab or something like that. Because it's got to be fully dry, otherwise you're gonna get a bad number, an inaccurate number.
Okay. Thank you.
Good question. All right. Any other questions? No? All right. So I'll put the crude yield in the chat. The next time we meet, we'll be doing some purity testing. So melting point. We're going to do an iron chloride test, and we're going to do check the pH. And there's one other test that we'll do. And then after that, the following week, we'll do the spectroscopic testing. So NMR and infrared. But for now, next week, we probably will not have a physical meeting. It'll just be like I'll assign like 2 labs just for you to complete or something like that. All right. Any questions from anybody?
And the percent yield part of the table, which ones do you want us to fill out? None of it?
None of it, because we can't calculate the percent yield until we get the actual.
Okay, thank you.
And the actual is based on the pure product, not the crude.
Right.
I have a question.
Go ahead.
Why is it okay to use just any for the crude number? How come we can all use the same one?
So now you can, because most of the samples they maxed out at the same mass. Under normal circumstances, you wouldn't. Like if everybody was working in separate groups, you would just use your own number. But because when we started, most of our samples had the same, not samples, but our salicylic acid sample, when we measured that out, it was roughly the same for everybody. Then it's you can kind of assume that the crude yield is going to be similar for all the samples.
Okay, thank you.
Yeah, but under normal circumstances, you are absolutely right. You would not do that. You'll get your own information based on your sample.
And I have a question as well.
Go ahead.
Where can I find the video to watch for the recrystallization quiz?
It's in the last announcement that I sent out.
Okay, and the quiz is due today, or you want it by next
It's
week?
open. Just take it. It's open.
Gotcha.
And I apologize for it not being open. I thought I hit the right button in Blackboard to make it available, but obviously I didn't. So, but there are 3 attempts on that quiz also. So it's no failure. Shouldn't be anyway, unless you just don't care. But I know y'all care because y'all paying money to be here. All right, other questions? All right, well, I'm gonna log out of the iPad.
Hold on, Dr. Russell.
Go ahead.
I was trying to see, are we supposed to be taking down these lab results too?
Yeah.
Okay, we taking down everybody's?
Yeah,
Okay.
the people who are here in person, you living vicariously through them.
Okay.
Yeah, so every time, whether you're here in person or not, the data that we collect, everybody's using.
Okay. All right, thank you.
Yep.
This is, man.
All right, anything else? All right, I'm gonna log out of here. All right, if there's nothing else, I'm gonna go ahead and log out, because again, the next step is just filtration and cleanup. So you can feel free to log out too. And next week, no lab. All right, and then the following week, we'll do purity testing. And then the week after that, we'll do spectroscopy. All right, y'all take care. Have a good afternoon.
Thank you, you
Thank
too.
you.
All right.